Yeah, thanks everyone for coming to the talk. It's good to be here. Maybe, has anyone built something with Rasa before? Just show of hands. 1, 2, 3, a couple. Okay. Just always good to get a sense of, don't want to talk too much about the basics if people are already quite advanced. But anyway, feel free to interrupt me with questions. Quite flexible in how we do this. I wasn't sure if I was going to have a laptop or just slides, so maybe if at the end we might have some time for live coding, we can play with some stuff. But yeah, very flexible, so if you have questions, just put your hand up, you can interrupt me. That's absolutely fine. So by way of an outline, I want to say just a little bit of context about Rasa, what it is, and then talk about the two things that we care about. So one is natural language understanding, and then the other one is dialogue, so holding conversations. And then we'll look at some of the pieces that you need to build a bot from scratch. And I'll have a link to a repo so you can all kind of, if you want, you can clone it and follow along with the notebook. OK, as promised, about Rasa. So Rasa is actually the biggest open source machine learning toolkit for conversational AI. And what we mean by that is taking chatbots and voice interactions beyond just like one question, one answer, right? Going towards something you can have a real conversation with. And we have quite a big community, and a lot of enterprises use it in production. So we have, I think, close to 200 contributors now across the open source libraries. And a lot of people in the forums helping each other out, building tutorials, writing blog posts. And that's something we're really excited about. So Rasa is kind of three different things. The first thing is it's a community of people who want to build open source conversational AI. Then it's also the open source project itself. And then thirdly, it's also a company. So Rasa is also the name of the startup Rasa. And we're the maintainers. And then we have an enterprise product. And so that's how we make money. Cool. OK, I like to start from first principles. Where does it all come from? What do we believe in? So the first is we really believe you need developers and you need product people to build conversational AI. So we don't believe in building like a point-and-click interface that you can quickly put something together. I mean, that has value, and that's interesting for prototyping. But if you want to build something really meaningful, you need to invest in your own people. You need to build up the skill set yourself. Conversational AI is really, really hard. And it's not a solved problem. So as a developer, it's kind of like building websites in the mid-90s. Everything still has to be invented. Nothing is kind of, you don't have these common patterns, like you can just kind of import things that have been solved for you. You have to really think about all these problems and come up with your own patterns still. So that's really exciting, but also means that it's very challenging. Yeah, like we said, this is important enough that you should be building up your own capabilities and not just relying on Google or Microsoft or someone to provide you with an API that does all the hard stuff for you. And finally, yeah, no fairy dust, no pictures of brains, no nonsense about artificial general intelligence, just open source implementations of ML. And that's our mission, is to empower makers to build AI assistants that everyone can use. Because I think actually making computers understand us and natural language is a really important part of making technology more inclusive across generations, across demographics. OK, so the Rasa stack is two pieces. So there's Rasa Core and Rasa NLU. And they do two different things. So a message comes in, like here a person says, and this could be text or voice. Rasa doesn't do any speech to text or text to speech. So it's assumed that it's in text form. So someone says, please send a confirmation to my email address. And then what Rasa NLU does is it takes that string and it turns it into something you can use, right? So it says, OK, what is the intent, right? So you predefine like a closed list of possible intents that people could be expressing, so the things they might be saying. So this person is not saying thank you or hello or goodbye. They're providing an email address. And then you want to pull out the entities, which are kind of the structured data that you need to get out, right? Things like emails, dates, the names of products, the objects that people are talking about. And then Rasa Core does something else. Rasa Core takes that information, what was the last message, and then it looks at anything it's learned from the outside world by calling a database or looking at APIs or anything like that, and the whole history of the conversation, and then says, what's the next thing we should do? And in this case, the database has told us that this email address they've told us about is not the one that we have on record for this person. And so the system suggests that we should ask the person if they want to update their primary email address, right? OK, so the first piece is natural language understanding. And within the scope of kind of dialogue systems and chatbots and voice interactions, this is what natural language understanding means. It means take a string and turn it into, well, a JSON or some kind of structured representation of what it means, right? So it means classify this message into one of n predefined intents and pull out these entities. And it's fine to call that natural language understanding so long as you remember that it's absolutely not true, because the computer doesn't understand anything. It's just now able to do this task of turning it into that JSON for you. But then, of course, the idea is that you can compress all the possible ways that people can express this information down into something you can use. OK, so how do we do it? So when Rasa NLU was first open sourced at the end of 2016, we really had the simplest model in the world. So maybe put your hand up if you've heard of word2vec or word vectors in general. Most people have, yeah. So you take a word vector for each of the words in the message, you add them up, and then you train a classifier on that to predict the intent. And the interesting thing about that is it really doesn't matter which classifier you put at the end of it. So you can put a linear model or an SVM or a neural network or a super deep neural network. It really doesn't matter. It doesn't give you any gain. The limitation of that model is only in the quality of the vectors, the quality of the representation that you're putting in. And it's one of those baselines that just is embarrassingly good and hard to beat. So it's very frustrating if you're trying to do something more clever, because a lot of the time you just can't get past or can't really significantly improve upon a really dumb baseline. But of course, there are limitations, and there are things that this kind of approach doesn't work. So the first one is out of vocabulary words. So that can be because someone misspelled something, or they used some slang that wasn't there in your data set that you used to train the word vectors. Or in a lot of languages, you just get this kind of difficult words, right? So this is a real word from a real project using Rasa, which is Zahnzusatzversicherung, which is a German word which means additional dental insurance. And of course, that's one word in German. And word2vec, or glove in this case, is trained on usually things like Google News or Wikipedia, right? And unsurprisingly, no one in the news has ever talked about buying additional dental insurance. So this has no signal, right? This is just a row of zeros. It has no meaning. And so if you're building a chatbot for dental insurance, you care a lot that that word has some meaning, right? And so for English, word vectors work quite well. For German, they work a little less well. And for a lot of languages like Finnish and Turkish and really inflected, morphologically rich languages, they work terribly. But in any case, there are lots of other reasons why you might have out-of-vocabulary words. Then the other one is domain-specific meaning. So word2vec is all about capturing the similarity between the meanings of different words. But if you're talking about money, or you're in a banking domain, then the word balance and cash are very closely related. But of course, the common use of the word balance is more closely related to symmetry, right? So if you're just using something trained on, again, news or Wikipedia or something like that, you might not capture the similarities that you care about for your domain. And then the other one is just the limitation of modeling this as a classification problem. And you're saying that everything that a person says has exactly one meaning, right? And a lot of the time, that's not the reality. So people functionally tell you multiple things in one message, right? They say, yeah, please, Owen, can you do this? Or, no, but instead, can I have this? And so it's a very common problem. So in any case, I don't want to go into too much detail, but in April this year, we pushed a different model to the repo, which overcomes these limitations. So what we do instead is we don't use any of the pre-trained word embeddings. We build them for your task, and we build them in a ranking way so that you can actually have multiple intents per message as well. So the short version is that NLU is easy, provided that you're just talking about the kind of canonical toy example of you know, I'm looking for a Mexican restaurant in the center of town, and you want to assign it to one of these intents and pull out the entities. But of course, that's not true because NLU is actually quite hard. So negation is a really simple thing that's hard. So if someone says, I don't want sushi, right, you say, well, OK. You look for the word not, and you look for what comes after. That's easy. But then if someone says something indirect, like I'd go hungry before eating sushi, you have no hope of catching that, right? This relies on like common sense knowledge of the world. You have no way of capturing that. And actually, the algorithm of looking for the word not and then looking for what comes after is actually state-of-the-art negation detection. So you can train like an LSTM on a huge corpus, and what does it learn? It looks for the word not, and then it looks for the next punctuation mark. It says in between there, that's what's negated. So it's really hard to do any better than that. So the cases that are obvious and the cases that are easy, and the cases that are hard are pretty hard. And it's actually, NLU is impossible. You can go one step further. So here's some examples. So let's say you're doing IT help desk, right? And you have these two sentences at the top. So can you help me log into my account? And can I give someone else access to log into my account? So like day one of your project, you might say, OK, you know, I'm not going to do everything. Those are both just questions about login, right? And maybe I don't have anything to do with login automated yet. So whatever, they're all treated the same. I have to hand this off to a human. So 3 months later, you have enough data, and you've actually automated one of these. And now you want to treat these differently. So the answer of do these questions mean the same thing, your answer actually changes over the course of a project. So you don't even agree with yourself 3 months ago about what's the correct way to assign intents to these sentences. So there is no universally correct way to assign an intent to a sentence. It only depends. It totally depends on downstream what you want to do with it. And then the other one, this is a great example from Andrew Kaler's work, who's somewhere in California. He's an academic. And he has these two sentences, right, which I love. So the company fired the manager who was hired in 2002 versus the company fired the manager who was embezzling money. And of course, those are very, very different sentences, right? The syntax is the same. They tell you roughly the same thing, that something happened, right? But if I tell you that the company fired the manager who was embezzling money, I'm assuming that you're going to make an inference that there's a connection between those two statements, and they're not just sort of randomly, you know, juxtaposed. And we're very far away from building NLU systems that can understand enough about the world outside to understand things like that. So anyway, NLU is very, very, very hard. OK. Any questions about NLU before we talk about dialogue? Yeah.
Can you look at like disambiguation, like since that's like where you're like, this is my niche, like I'm dealing with insurance in Germany. I want to look for common words and augment my corpus that I'm going to train on. So can you use the sentence? There's like multilingual syntax too.
Yeah. Definitely, yeah, yeah. So you can do things like that. We supervised 2 master's students this year, and one of them was looking at exactly that problem of can you take like an in-domain corpus and a generic corpus, and then combine the information from the two. So we tried a couple different things. So one was Stack Overflow. So train word embeddings on Stack Overflow questions, and then also on just like regular, like Wikipedia or whatever it was, Common Crawl. And then, you know, in the Stack Overflow thing, of course, you can tell that Python and Ruby are related words, which in Common English, they're not at all related. So that's interesting. You can get a performance boost, for sure. So it's definitely worth, if you want to go, so that's why I say, if you want to go kind of beyond the limitations of a bag of words model, the first thing you should do is try and get better word vectors, doing things like that, looking at a domain-specific corpus, rather than just trying to find a fancier classifier. Yeah.
Do you think that the NLU problem needs to be solved for every language in a separate way, or do you ever like imagine there's going to be a solution that can basically work with any corpus? Like you mentioned, Finnish and other languages are different and very hard.
Yeah.
Do you think is it going to be the same? Or?
I mean, this is a big debate in NLP in general, right, and especially among linguists. because the vast majority of research papers just deal with English, right? And then there's some tail that deal with non-English. And then the question is, can you like solve all the problems in English and then it will just kind of diffuse and solve the problems in other languages? I think for a lot of things, no, it won't, because languages are genuinely quite different. But I would also say that I'm not a linguist, so probably not the expert to comment on that. Yeah. Yeah.
Which problems are more valuable to solve first with other languages? Are there certain languages where there's more value, like when you're trying to provide value for products, like that are spoken for my people, or sorry, I'm thinking by more people, or
Yeah, I mean it's a question of strategy, right? Of which problems do you want to tackle and for whom?
the market, like sometimes there's more people speaking this language, but it's hard to get paid.
Right, exactly. They might not have a lot of money, so then they're still marginalized, even though there's hundreds of millions of speakers of that language. Yeah. Cool. Any other questions? Yeah.
You mentioned having to specify the intent. Kind of like recommendations for if you were to try to like learn new intent.
Yeah, I mean, you can take, if you have a data set of things that people say, then you can do, you can take GenSim or like a nice topic modeling library and, run it over there and see what things it picks up that people are talking about. But practically speaking, the question is, what are you going to do with it afterwards, right? And you need to have some kind of goal in mind. And there's always going to be a long tail of things that people want you to do that you're not able to automate yet. So the most valuable thing is just have a first guess and just get it out there and give it to people and just see. But if you have like a corpus of things that people are already asking you for, then that's like a great resource. And then, yeah, doing a topic model or something would be a nice way of figuring out maybe what are the things that people ask about. Cool. Okay, so dialogue. Dialogue is also a very hard problem. So when you start building a chatbot or a voice app, for Echo or Messenger or whatever it might be, you start off assuming that people are going to ask you good questions, right? So here's an example from a banking domain, and somebody asks a well-qualified question like, which savings account has a better interest rate? And you can answer that. But of course, what happens is that people refer or implicitly expect you to remember the context of the conversation. So they ask you something like, which of those has a better interest rate? And then if you're covering maybe two different topics, it's a very simple chatbot. All it can do is recommend savings accounts and mortgages. Then even the word better has the opposite meaning with respect to interest rates in those two contexts, right? So then, well, how do you do that? Well, I mean, you can treat it like an ANAFRA resolution problem, which means that you try and explicitly say that the word those refers to something that was said earlier. But that's not what people do. What you do is you build a state machine. This is what everybody does. So you say, OK, well, I have two things I can talk about. And if the user starts talking about one, then I'm going to push them into this state. And then I'm going to define some rules for how you can navigate this graph. And so that's what it looks like on day one. And then day 100, a few months into the project, you get, and this is a real number, I didn't make this up, it's actually, I think it's 35,000 lines of XML. This is a major online booking platform, and that's how big their state machine got. And that obviously becomes incredibly hard to maintain, because if something goes wrong, who wants to debug 30,000 lines of rules? And here's another real example. And this is a very simple chatbot which can give you a quote for car insurance. It can do one thing, and it can answer a couple of simple questions. Yeah, this is a real graph. So Rasa Core will actually look at the conversations that you feed to it as training data and produce this, which is an approximate representation of the kinds of conversations people can have. Just also to help you see how complex this is, right? Because it's very easy to kind of forget, because it's so natural for us to know how conversations go, that if you actually try and write it down, you don't realize how complicated it is. And that's also really the whole kind of core philosophy behind Rasa Core is that just don't do this. Don't try and reason about all possible conversations that people could have. Just learn from real conversations. Because there's this huge asymmetry, right? On the one hand, if a chatbot does something stupid in the middle of the conversation, you can show that to your 4-year-old niece or nephew and they'll know that that's dumb. But then to go back to your 30,000 lines of XML and figure out why it went wrong is really, really hard. So the whole idea behind Rasa Core is like, don't even try to figure out why. Just create a new training example and then teach it. So that's what Rasa Core is all about. It learns to have conversations from real examples. So here's a figure from a recent paper of ours where people are, this is in the hotel booking domain. And anyway, I don't want to go into the details about what the figure shows. But the point I wanted to show here is that what Rasa Core sees is not what Rasa NLU sees. So like I said, Rasa NLU does the job of abstracting over the surface form of what the person said. And then what Rasa Core sees, when it does dialogue, it only sees this kind of abstract representation. So you as a developer, you define like the list of things that your system can do. So things it can say to the user, API calls it can make, database queries it needs to run. And then Rasa Core's job is to predict which one to do. So this column in the middle, that's what Rasa Core sees. That's the training data for Rasa Core. So it looks at real conversations and then learns how to have them. So rather than defining like a bunch of if-else logic, you provide example conversations. Sorry, I exported to PDF, so clicking through doesn't work here. Yeah. Okay, the interactive learning point is just something we did with the library that you can give feedback to Rasa Core while you're talking to it. Because like I said, it's really easy to know in the middle of a conversation what's right and what's wrong, but it's hard to kind of reason about that in the abstract before you start working. So with Rasa Core, you can teach the system by talking to it, right? And that's really the focus, as well as learning from real data. Okay. How are we doing for time? Oh, we've got loads of time. Cool. So then I just wanted to talk through some of the pieces that you need so you can see kind of what the code looks like for building a bot from scratch. But any questions about dialogue, this would be a good time to ask them.
Do you need to define what those things on the left, ask location, chit chat, what those are, or do those get discovered?
Right, so it's a great question. So the lines that start with a star are the output of Rasa NLU. So that's the intent and the entities. So if the person says it's for 2 people checking out May 26th, that's the inform intent, and those are the two entities that we extracted, the end date and the number of people. Does that make sense? So those you have to predefine, and that's the output of Rasa NLU. And then the other one, the lines that start with a dash, those are what the system should do. And actually what's implicit that's not shown here is that Rasa Core itself has to predict that it needs to listen. So it will just keep predicting the next thing to do until itself says, hey, I should wait for more input from the user. So that's why some of these, it only does one thing, and some of these, it does 2 actions in a row, right? And so what we do in this paper is actually we show that, I mean, okay, the thing that makes conversational AI hard is the unhappy paths. Because like the happy paths are easy, right? You ask the user for what you want them to tell you, and you just, they tell you. But what we do is we study different ways that people deviate from that kind of cooperative behavior. So either they make some chit chat, or they ask a question like, why do you need to know that? Or they ask a general question like, are we done yet? Or they change their mind about something that they said earlier. And what we do is we learn how to deal with that behavior in one domain, and then we have a test domain where we then have to do like a transfer learning thing. So we do, in the training set, we have restaurants as the domain, and we have a bunch of examples where people are being uncooperative in a restaurant domain. And then in the test, it's a hotel domain, and we haven't seen uncooperative behavior there, and we see how well the dialogue system can learn to do, like learn these really generic dialogue patterns, right? Like if someone makes chit chat, and you're not currently completing a task, then just respond with chit chat. But if they're in the middle of a task, then you respond with chit chat, and then you go back and repeat the last thing you did. So kind of these reusable pieces of dialogue are really the thing you want to learn. Yeah.
You mentioned the interactive learning. I guess
Yeah.
that's some kind of feedback loop. But if something is wrong, how do you know it's something from the dialog piece or from the NLU piece?
That's a great question. I mean, the output is quite verbose. So it will tell you, here's what NLU thinks it means, here's everything that happened so far. So you can see the kind of the verbose information of what's happening. Yeah. Other questions? Cool. All right. Then, yeah, just look at some of the pieces. OK, a bot from scratch. Start with thinking about conversations, right? Write down some conversations, how you think they might go. So this one, oh yeah, there's a link there. So if you want to sort of clone the repo and build a bot that can recommend you Shiba Inus, it's obviously high impact stuff to be building. No, it's a really cool tutorial. Justina, our developer advocate, built this. It's really fun. And it's like very, very thorough. The documentation's very good on it. Yeah, this user is not being very happy. The puppy didn't cheer them up. But I mean, really, it's a good thing to it's a great exercise rather than starting with defining your intents and your actions and your utterances and everything. Just start writing down a couple of conversations and then convert that into your initial seed training data. And then as quickly as you can, give it to people to test. So, OK, the first thing is the NLU data. For Rasa NLU, this is what the data format looks like. So it's markdown. So it's kind of easy to read, easy to manipulate. So we group things that people say by the intent. And then if you have entities in there, they're just like links in markdown. So you square brackets here around the word puppy, and then round brackets animal. So we're telling Rasa NLU that to extract puppy as the entity, and the name of that entity is animal. So the same way that Mexican might be the name of the cuisine, or North might be the name of the location. So that's how you do entities in there. So you, like I said, you have to define the kind of the universe of intents that you're supporting, right? And then you want to take some of those conversations that you wrote down that you think people will have with your system and convert that into this abstract, these stories, we call them. So this is the training data for Rasa Core. And so you want to convert, just a couple. Just start with half a dozen or something like that. Or you can just build them up by talking to the system. That's even easier. But just write down what these conversations would look like and create the first bit of training data for your dialogue system. And so Rasa Core, there are two different things that your system can do. Well, there's only one thing it can do, which is to execute an action. But the simplest kind of action are just utterances. So just send a message to the user, right? So those are all the ones that start like here with utter. Let's just send a message, don't do anything. But in general, an action can just execute an arbitrary function, right? And so here we've created one called action retrieve image, which we then have to implement. So this says, do something, go fetch an image of a puppy for this person, this poor person, feels terrible. And so you have to implement that action. You have to tell it what to actually do when it encounters that. But in the training set, or in the training data, it just looks like that kind of abstract representation. And then to combine that, you have to define what we call a domain. So it's just a YAML file, which you feed to Rasa Core. And you say, this is the universe that the bot lives in. These are all the intents that exist. These are all the entities that it knows about. And these are all the actions that it can execute. And you can provide some templates for these simple actions where the bot's just sending a message to the user. Yeah?
Are there any open data sets for intent or domains?
I mean, the domains are very, very domain specific. But then for NLU, are there examples of data sets with with real people's utterances, you mean, kind of grouped by intent? Yeah. We have a couple that we link to in the repo, but they're not great ones. So there's some that you can help get started, but I can't yet say, I would love to say that, and I'm sure I will stand up here and say that at some point, but we don't yet have a really great open data set that you can use to get started with. So yeah, you kind of have to source it. But I mean, ultimately, it seems like you need a lot of data, but actually as soon as you give it to a few people to test, a few thousand messages happens pretty quickly. So it seems like a lot, but it's not actually that bad. Cool. Yeah, so then you define a domain, and then in your actions here, the custom actions that are actually functions, or they're actually classes, you just provide the path to them so that the Python interpreter can find them and execute them. And so here's what the custom action would look like. So you define it as a class, retrieve image. It needs two methods, name, which is the name that you have in the training data, and then run, which says go do the thing, and report back what you found. So in this case, we're just doing requests. We're doing a request.get. We grab the animal that the person asked for, and we go to this Shiba Inu API and fetch exactly one image, and then send it back to the user. Here's something to cheer you up. So in general, that's how Rasa Core works. It learns about the outside world by executing these actions, and the actions can report back, here's what I found, right? So I found that this is a premium user, or this is a free user, or I can report back that, there's no such, that we don't have any pictures of ducks. This person asked for a duck, but unfortunately we don't have any pictures of ducks. And then you have to have, of course, conversations that show then what the system should do in each of those cases, right? So Rasa Core needs to know how to use that information from the outside world. And then, yeah, the best thing you can do is just give it to your friends to test as quickly as possible. Test it out yourself. It's 1,000,000 times more useful than just kind of agonizingly debugging things. Your users will always surprise you, always. So, it's better to be surprised early, I guess. So yeah, get stuck in. So we have pretty good docs, I would say. There's some parts of the docs that are interactive, so you can try it out without installing anything, especially for people who are new to Python. Those of you who are not new to Python, you know that sometimes installing NumPy and Anaconda and all that can be a pain. So we try to make it easy in the documentation. And then we have a forum where you can ask questions, and there are lots of people there answering them. And you can probably find questions that other people have asked the questions that you had, and you can see the answers without waiting for a response. OK, so take-home messages. Number one, point and click doesn't work. You need real developers. You need real engineering teams to build conversational AI. Two, conversational AI is not a solved problem or even close to being one, but you can actually build meaningful things. I mean, Shibas are fun, but I didn't want this to be like a vendor talk, so I didn't want to talk about case studies or anything like that. But whatever you're doing, check it out. There's plenty of examples of people building really actually impactful, meaningful things with conversational AI. Third one, I can't stress this enough. Real conversations are more important than hypothetical ones. So don't stress about building your flowchart of what might happen. Give it to people and see what does happen. And yeah, finally, just a reminder, what are we all about? What do we see ourselves as doing? We ship a lot of applied research into open source libraries so that everyone can actually build better, more meaningful contextual AI assistants. And finally, yeah, if you want to move somewhere with cheap rent, you're tired of the Bay Area, you want to come to Berlin and live the dream, then give me a call. Get in touch. And thanks for listening, and thanks for all your questions.
So we have some time for additional questions. If anyone has any, just raise your hand and I'll bring you the mic.
I may be building a proof of concept soon,
Cool.
and I'd like it to be, it's more for an embedded application. And so what kind of performance requirements what would I need to run a model, to run a chatbot? It'd be a single
embedded,
user, but...
Sorry?
I'm sorry, it'll be a single user at a time.
It'll be a single user, but are you, like, how embedded? Are you talking like Raspberry Pi 0 or below or above?
Well, that's what I need to tell the customer.
That's what you need to report back.
Yeah.
You can do a lot with very simple models. I mean, so if you use the pre-trained word vector model, you need a couple gigs of RAM. So that's out of the question, I guess, for you. But you really don't need that. So you can definitely do something on kind of a Raspberry. So I would say try it out. Okay. Yeah, because it tends to be small data with respect to other deep learning applications, right? It's not like you have high-resolution images or streaming video or waveforms or something like that, right? It's a small amount of text and a small amount of conversations. So you can get quite far with not a lot of resources. So people who are running Rasa in production, they typically don't have GPUs for inference or anything like that, right? So it's just running on a CPU box.
Okay, great.
Any more questions?
Great talk, thanks. I wonder if you could put the slide up with the demo link on it so I can write it down.
Of course. Yeah, sorry about that.
Thanks. It's not actually,
There you go.
well, I guess a small question.
Does the repository have like issues tagged that they want people to contribute to, or for the Rasa?
Yes, we do make an effort to encourage new contributions. And for us, the guideline for good first issue means it might be easy, it might not be easy, but it's well isolated. So good first issue means it doesn't require knowledge of the whole architecture of the whole library. But yeah, we really try, and if you have an idea for an enhancement or something like that, just create an issue, tag it. Even if you're not sure how to implement it, we try and respond to every issue in less than a day. So we'll get back to you and with some comments. Yeah.
Can you talk about a little bit about use cases, say outside of what typical, say, Alexa or Siri dialogues that you can achieve using Rasa?
Yeah, so use cases outside of the typical Siri, Alexa example. So one that I really like, so one of the ones that's obvious and everybody always talks about is customer service, right? Especially kind of top level customer service. What is the high volume, easy things to automate? That's fine, and that's cool, and you can obviously get some wins there. But one that I really like is Helvetia. This is a Swiss insurance company, 160-year-old Swiss insurance company, and they sell home insurance policies, and they're 5-year contracts. And they have this long tail of customers whose contracts are about to expire, and because the labor costs in Switzerland are high, it's like the Bay Area, it's literally not worth their time to have someone call them up and say, would you like to extend? So what they did was they built a bot with Rasa over text, so over SMS, and reach out to these people and say, hey, did you know, you've got, in 3 months, your home insurance is going to expire. Has anything changed in your circumstances? And it would kind of help them figure out if anything changed. Maybe they got a piano or a new car, or I don't know, they built an extension or whatever. And then we give them a new quote, and if they were happy with it, they're just automatically submit it and say, okay, your new policy's in the post. And the crazy thing was, it was over 30% conversion compared with the baseline of 0, because they weren't doing anything. And your cold outreach to customers, so that's pretty good. And the first, because everyone says, oh, chatbots, millennials, whatever. Actually, the first person to buy an insurance policy there was a 55-year-old Swiss lady. So I think and it was over text message. So I think kind of the opposite of a lot of the assumptions that people make about what you can do with bots, right? It's actively outreach, different demographic from what you might expect. So that's a really cool case I like.
But how much is that contributes from the NLU and dialogue versus to just ask them about, you can measure, comparing, is there any kind of measurement between having an intelligent dialogue system versus just send people spam texts, ask them to renew?
Oh, so you have to walk the person through the whole process, right? So it's not just here's a 200-word message with all the details, right? It's it's a process. And what's really important is to have the actual back-end integrations, right? So people do, if you just say to someone says, I lost my credit card, and you say, here's a link where you can request a new credit card, okay, fine. But if you actually have the back-end integration implemented so you can say, all right, the new card is on the way, it's obviously 100 times better, right? So you have to, and that's also why we think companies should be investing in this and building it themselves. So to get the real value add, you want to be integrating it with your own system so you can actually automate things, actually get a quote, close the deal, send it out.
Sure. I got 2 questions.
Yeah.
The first one is, for the chatbots, how does it handle the common situation like the F words, taboo words like the Microsoft bot experienced in the past?
Yeah.
Yeah. The second question is what's the advantage of using this framework instead of like building say like your own model trained with such as ASTM, RNN on top of the NLTK and that kind of thing?
Yeah.
Thanks.
Yeah. Cool. So the two things are, the first question was, oh, right. So Rasa Core predicts what action to execute, right? And if that action is just send a message, right, you just fill in you write the templates for the things your bot can say. So we don't do like just learning on unsanitized text to just like generate a response, right? I mean, NLG, we will get there, as a field, but I think it doesn't make sense right now. And then of course, but the question is if your users are being abusive, right? So then, yeah, you need to define an abuse intent. And again, like catching 80–90% of abuse that people send to your bot is easy, right? Because it's just the usual words. But some friends of mine were working on the Alexa challenge, and some things that you wouldn't necessarily think of as abusive. So they did the NLG, right? So or it was actually retrieval. So it was trained on like data from the internet, and they obviously had like blacklisted lots of terrible words that they didn't want to ever send back to the user, but they could still say things which are really inappropriate, right? At one point, I think the system said, I can sleep with as many people as I want, which is horrendously inappropriate, but it doesn't contain any words that are, necessarily wrong. So, but in terms of catching abuse from your user, that's actually relatively easy. You just have to know then what to do with it. Yeah.
I'm not sure how relevant this question is, but how would you compare Rasa with other existing chatbot frameworks such as Alexa or Google Home and frameworks like that?
So, so compared to the cloud solutions, it's not a cloud solution. That's already good, right? It's open source, which means you control your data. So the Microsoft Google model is, we have magical algorithms, upload your data, and everything will work. Right, what we say is actually that doesn't work. There's no one size fits all. You should think about your model, your data, your hyperparameters, and also it's not magic. You can look at the code. It's just statistics. So run it on your own machine, run it on-prem, build your own stuff. And what we see more and more is like the advanced companies who've been using Rasa for 6 months or a year, like build their own components, right? They start to sort of subclass pieces, they customize it. So you have customizability and flexibility, and then the fact is that no one else has to see your data, right? So you can deal with sensitive data or strategically important conversations without just kind of offloading everything to Google servers.
I have a follow-up question.
Mm-hmm.
So what's the difference between open source Rasa and the enterprise solution that you offer for our clients?
Yeah. So all the machine learning stuff is open source. Okay. So the way we think about it is that if you're a developer or a couple of developers, the open source should be everything you need. So we don't have like magical algorithms or something that you have to pay for, because there's no such thing. What we do in the enterprise version is we provide extra tools that sit alongside for running this in an organization at scale. So things like versioning and rollbacks and API integrations and a user interface and all that stuff, all that good stuff, logging and auditing, security, all of that. So it's kind of all the important stuff you need to actually deploy this in an enterprise. That's what we charge for. Mm-hmm.
Any more questions?
I can just speak loudly. I just a basic question. I want to know what other open source libraries you depend on with Rasa, and do you ever contribute back upstream?
Yeah, great question. So Rasa NLU and Core, they're both kind of the Keras idea. So I was really inspired by that library when we started, is that we do a lot of the hard stuff of getting everything into like a machine learning format, like an X vector and a Y vector. And then like what machine learning library you use at the bottom, we don't really care. So for Rasa Core, you can use Keras or TensorFlow or scikit-learn, right? And Rasa Core does the job of keeping track of the conversation and converting that into an XY format. And then you can, if you want to have your own classifier there or something, you can do that. And you just need to implement like a train and a predict method that wrap whatever framework you're using. So I always encourage people, don't just use the default classifier, default hyperparameters. Go in there, play with stuff, play with the vectorization, the featureization, with the loss function, everything. Yeah.
Going once, going twice. Okay, let's give Alan another round of applause.
Thanks, everyone.